All right, let's look how to do this problem where it's asking us to test the claim that fewer than 32 students is the mean class size for a full-time faculty. Okay, so that's the alternate hypothesis. That's a less than 32. So this is a left-tailed test. So we're looking for the less than 32 in the alternate, and that would mean greater than or equal to 32 is the null. So that's the one we're looking for. And then we want to find the p-value. Okay, so to do this, I'm going to copy this to my clipboard, Control C. I'm going to take this into Desmos. All right, I'm going to paste it. And anytime you have a data set like this, I just call it like something like A, just capital A. And then I can do things like mean of A, and then STDEV, standard deviation of A. So this is a sample, so this is the mean and standard deviation of a sample. Right, remember, if you want a population, you have to put .p in there, or sorry, p, not .p, just p. But this is a sample. You can see it's different. It's a little bit bigger when we do a sample. All right, now I need to do a t-test to do this p-value. So this is a left-tailed test. So I'm going to type in t-dist. And then the first thing you want to put in there is the degrees of freedom. That's one less than your sample size. So that's going to be 17. All right, now the shift. You got to be careful here. You don't want to use this as your shift, 30.88. You want to use the claim mean as your shift. So 32 is the shift. All right, but you do need to use, for the scale, you do need to use this standard deviation in the square root of your sample size. So don't forget, it's I'm going to do 4.33. I'm just going to round it to 4.33. I'm going to do the 7 since the next number is a 0, and then divided by SQRT is square root, and then 18 is my sample size. So you should also always see this number n, and then this number right here is n-1 when you do these t distributions. Okay, the p-value is area, so we're going to do cumulative probability. This is a left-tailed test, so I'm going to select left. I want area because it's a p-value, and I want to go below this mean, so this 30.8889. So I'm going to put in 30.888 and then just round it to a 9 at some place value. And then there is my p-value for this problem. All right, it tells me to round to 3 places, so 0.146 is what Desmos gives me, so that's my p-value. All right, and then what do? Do I reject? Do I fail to reject? Alpha they're wanting me to use is 0.1. This is bigger than alpha, slightly bigger, but it's bigger, so that means I'm going to fail to reject. Why do I fail to reject? Because the p-value is greater than alpha, which is the significance level. So the p-value is the likelihood to see what we're seeing, and 0.1 is the cutoff. The alpha is the cutoff for what we're going to accept is left to chance, because we could get something crazy with it still being true. Remember, alpha is the probability of a type 1 error. We could get something that's crazy, but anything below 10% chance in this one is what we're saying is too far. But we didn't get there. We didn't get to that number. All right, and then with these interpretations, just make sure that you understand it was fewer than, that's a less than, so that's still going to be what we compute. So there's not sufficient evidence to support the claim that it's fewer than. So that's C. Okay. B is tempting because it's the, I see there's not sufficient evidence, but it says more than. So just be careful. It goes back to the original claim. All right, let's just make sure we got it down. So here's the next problem, very similar. This one says we're going to test the claim that the mean number is. So that's the null hypothesis. So that's equality in the null. The mean equals 11, and that means not equal to in the alternate. So that's going to be choice D here. Okay. So if it doesn't imply a direction, that's the null hypothesis. All right, let's grab our data, copy it, Control C, and then we will paste it into Desmos just like we did before. All right, paste. Again, call this A or B or whatever you want to call it. All right, we want the mean of A. We want the standard deviation of A. All right, and now we're ready to make our distribution. So t-dist. Again, this is t because it's about a mean I don't know the population standard deviation. I'm using a sample. All right, degrees of freedom, 1 less than this, so that's 7. All right, the shift, that's not the mean. The shift is the claim mean, so that's going to be the 11. So we're going to put 11 in there, and then the scale, standard deviation here, you can actually just copy that if you want to, divided by SQRT of the sample size, which is 8. All right, once you have all that in, you're going to click cumulative probability. Again, we're trying to find a p-value. P-value is area, so it's a probability. And then you want, because this is a two-tailed test, right? This is, the last problem we did was a left-tailed test. That was a mean less than. This is not equal to. So I could be above or I could be below. So I'm going to do a two-tailed test on this one. Now, you got to be a little bit careful here with the two-tailed test. This 11, that's our population mean. This is our sample mean. So you can see I am below the sample mean. So take the sample mean that you got, subtract the population claim mean, and that's how far below we are. Okay. You could also be above that because of two-tailed test. You have to go below and above. So we're below. That number is below 11. So I could also be this much above 11. So take that number that we just got and add it to 11. And these are the two numbers. I'm going to do outer, because let me zoom in on this so you can see it. That's below and above. So I'm going to do the lower number, the 9.837. That's the number that we actually got for our sample mean. That's below 11. So when I paste it in there, you can see we're down below 11 there. And then this is the number that I got. That's the same distance that 9.8375 is below 11, above 11. So like that symmetry, like how far they are from the middle. That's what we have to do in a two-tailed test. This is our lower p-value, but we also double it and find the value above it. Okay, so that's the number, 0.306. Okay, another way you could achieve this number is just look at where this number is. This number is below 11. So since it's below, now I could choose left and just use the lower number, the number that I have, get this number, right? That's just the left tail, but I would have to double that number. So times 2. And that is another way that I could get that p-value. Okay, but you do have to double it if you do do the left tail test, because there's two tails here. There's the below and the above. So it's kind of like I'm doing the left tail test, but then I'm mirror imaging it into the right tail. All right, so you got to make sure that if you have a two tail test that you do that. All right, to 3 places, that was 0.306. Oops. 306 is what I got. All right, check my answer. All right, and then same thing as before. What do we do? That's much bigger than alpha, so I'm going to fail to reject. Why do I fail to reject? Because the p-value is greater than alpha. So there's that. And then on the next part, what just happened? Right, at the 1% level of significance, there was, again, not sufficient evidence. If there is sufficient evidence, that meant that p is less than alpha. So there's not sufficient evidence, so it's going to be either A or D. And then what does there not sufficient evidence to do? In this case, the claim was the null hypothesis, so there's not sufficient evidence to reject that claim. So that is D. Okay. Notice that choice A was there's not sufficient evidence to reject the claim the mean number is less than. That's not what it was. The null hypothesis had equality this time, and that was the claim. So just, again, you have to be careful with the way it's worded on that last part.